It's time to put what we have learned into practice. So let's go over to our demonstration portal and let's put out some of these things into practice. So I'm creating two variables again, N1 and N2, that will stand for number 1 and number 2 respectively. And let's just place some values into N1. So let's put 10. And for N2, we're going to put 5. And we want to do some comparisons. So we're going to make use of the if statement. If we just have a look at the syntax, it is the if keyword followed by a condition in the parentheses. Then there's a begin and an end to indicate where the codes that are associated with the if are going to be placed. So let us set up our structure. So if N1 is equal to N2, then let's begin and end, and let's do a cout. And let's simply put a message that says N1 is bigger. At the end of the if, we're going to put a statement that indicates end of if. So that we know whenever we hit this statement, end of if, we know that the if statement has terminated. And right below that, we're going to put another print statement that now says end of program. And we're just going to put some new lines at the beginning of each statement so that each statement can be displayed on a new line. So there we go. Get rid of the excess spaces, and we are going to execute. So we are seeing here that it's saying end of if, and then following that it says end of the program. We are not seeing the message that says N1 is bigger. And the reason for that is we need to examine the condition. So in the conditional statement, it's asking if the value in N1 is equal to the value in N2. Just by looking at the values, 10 is in N1, N2 has in 5. So it means that they are not equal. And because they are not equal, it means that we have not entered the if statement. So lines 21 would not be executed. Let us make it a case whereby the values are equal. So I'm going to put 5 and 5. And I'm going to change the message to say that N1 is equal. And is equal mean that it is equal to N2. We're going to re-execute. And this time, notice that we have entered the if statement because we are now printing the value N1 is equal, as we should, because these two values are equal. So this condition now equates to true. So let's put back the 10. And this time, instead of using the equal sign, let's use the greater than sign. And now we're asking the question, is N1 greater than N2? Just by examining the values, N1 has in 10, N2 has in 5, so N1 is indeed greater than N2. So we should be seeing the message that says N1 is, let me change the equal to bigger. So it's now going to say N1 is bigger. And then we should see end of if, because we would now reach the end of the if statement. And then we would have end of program because we have now reached the end of the program. So we execute. Note it indicates that N1 is bigger. And then we hit the end of the if as stated, and then the end of the program. Note though, that in this case, we are not seeing what to do when the condition is false. And that's because we do not have the else statement. So we can say that N1 is bigger, but what if N2 was bigger? We have nothing here to take care of that. So we're going to put an else. And inside the else, we're going to reverse the statement by saying that N2 is bigger. And the key here is if it checks N1 and N1 is not greater than N2, then it means by default that N2 should be either greater than N1 or equal to N1. But for now, we are not concerned about the equality. We're just talking about the greater than. And we're going to assume that the two values are different. They are not equal. So in this case, N1 is greater than N2, so we should get is bigger. So N1 is bigger. But what if we change the values? So N2 is now 50. And we re-execute. Then note the message now says that N2 is bigger because this condition on line 19 would now be false because N1, which is 10, is not greater than N2, which is 50. So this statement is asking, is N1 greater than N2? Or in other words, is 10 greater than 50? Well, that is false. And because it is false, we would now go to the else statement. And the else statement says, whenever we reach there, print that N2 is bigger. So this is the if else or the double if. But we could also convert this into an if else if, which is the multiple if statement. And we could do that by using an else if. So else if, and inside, we're now going to reverse the order. So we are going to ask or check if N2, sorry, is greater than N1. And if it is, then we print that N2 is bigger. So in this case, once we change any of these values, program will work smoothly in terms of telling us which one is bigger. So in this case, N2 is bigger because N2 is 50. But if we change N1 to be 100 and we re-execute, then now it says that N1 is bigger because N1 would now be 100. Sadly, this does not take care of the equality. So if we wanted to add the equality, then we could add an else. Because if N1 is not greater than N2, and if N2 is not greater than N1, then that means that they must be equal. So let us add that to the mix. And we can say both are equal. And in this case, just to test it, we can now put 50 and 50. Because we have already tested the case where N1 is greater than N2, and we have tested the case where N2 is greater than N1. So now we are testing for equality, and we are seeing based on the message, both are equal. And that takes care of all the conditions, the if else, and the if else if. As was mentioned earlier, if we had other criteria that we were checking, then we could simply add another else if into the mix. And we will put the appropriate condition into the else if. For example, if we now had N3 and we had N3 being assigned the value 120, then we could now check to see if N2 is greater than, well, let's put is less than N3. And the message in this case could say N2 is smaller than N3. So let's execute again. And note we're getting the message N2 is smaller than N3 because N2 is 50 and N3 is 120. We're comparing on line 29 to see if N2 is less than N3. it is less than N3, so the message N2 is smaller than N3 is going to be displayed. So that's an example there of how we can add multiple if statements into the if construct. In this example, we have been looking at at integers, but we could have done the same thing by looking at strings. So let's quickly convert the data type from integer to string. And what we now need to do is to add some string values. So let's add Bob. Let's add Amy. Let's add another Bob. Let's create a few more variables, N4 and N5. Let's have N4 being equal to Bob. Notice that in this case, Bob is a capital B. And let's say that N5 is equal to Amy with a capital A. I'm going to get rid of most of this so that we can look at it slowly, moving through each iteration. And let us compare N1 with N2. And this time we want to know whether or not N1 is bigger. So remember, these are now string values. Let's see if the program will actually compute. All right, so there is an error here because we have neglected to put the semicolon at line 17. So I'm going to make that adjustment. Let's go again. And notice it's saying that N1 is bigger. In other words, Bob is a bigger value than Amy. And in order to understand why, we need to have a look at the ASCII chart. Whenever we're dealing with strings, the ASCII chart becomes important. If we examine the ASCII chart here, please note that each character is represented by a decimal number. For example, capital A corresponds to the value 65, whereas small a is associated with the value 97. So in other words, small a is bigger than big A because 97 is bigger than 65. So what obtains in terms of string comparison is that we're going to process each character and compare them, or put it another way, we're going to go through the string character by character, compare each corresponding character, and determine whether or not they are bigger, smaller, or they are the same in terms of the ASCII values. So if I apply that same scenario to Bob and Amy, we would be comparing small a with small b. And if we look at the ASCII chart, then small a is 97 and small b is 98. Therefore, Bob, or the string beginning with B, would be greater than the string beginning with A. And that's exactly what is being demonstrated here, where we are seeing that N1 that has in Bob is bigger than N2 that has the value Amy. Let us now check Bob with Bob, meaning we want to check Bob that starts with a common letter with Bob that begins with a capital letter. Once again, going back to the ASCII chart, we know that the common letters are all going to be greater than the capital letters, simply because the numeric values associated with them are going to be larger. So note 97 going down to about what, 121 is going to be all greater than 65 going down to about 90. So we want to compare N1 against N4. And we want to determine which one is bigger. We execute. Once again, N1 is bigger because the common letter will be greater than the capital letter. Next thing is, what if we want to compare Bob with a big B against Amy with a big A? So that means we want to compare N4 and N5. So N4, N5. And if we go back to the ASCII chart, please note that capital B, 66, is going to be greater than capital A, which is 65. And given that, it means that Bob with capital B is going to be greater than Amy with capital A. So let's try that. Once again, N1 is bigger. In this case, it should actually be N4. Okay, so that the message is actually clear. So notice it indicates that N4 is bigger. So therefore, we know that Bob is bigger than Amy. And what if we want to test Amy and Amy for equality? So Amy is N2. That's Amy with a small a. And Amy with a big A is N5. We want to check these for equality. And let's just add an else to it. And so for the else, we can say not equal to indicate that the values are not equal. And if the values are equal, we can simply have a message that says equal. So note we are comparing N2, Amy, with a small a, with N5, Amy, with a big A. We want to know whether or not they are equal. So the values are the same. It's both Amy's. But because of the uppercase and the lowercase, there is a distinction. We execute, and note it says not equal, which is no surprise. Because we know that capital A, which is 65, or represented by 65, is totally different from common A, which is represented by 97. So the same way in which we treat integers, we can treat strings by making use of the comparative operators that we have looked at. The equal sign, the not equal, the greater than, the less than, the greater than or equal to, and the less than or equal to. And I would encourage you to take this knowledge and do some experimenting on your own to ensure that you understand how to set up conditions. Because conditions are going to be extremely important when we move on to the next control structure, which is repetition.